Okay, so hello everyone, good morning. I know it's a bit early, but just let me know if you have any questions in the meantime. I usually leverage these few minutes before the lectures and tutorial to address any specific questions you have in case you didn't have a chance to come to the office hours. So if you have questions, please post them on the chat as we usually do, and I will do my best to address them at least until we start the tutorial time. Okay, Aman, go ahead. Yeah, go ahead with your question.
Can I just talk, or do I
Sure,
need to type in?
that's even better. Yeah, go ahead.
Okay. So basically, I was working on my lab, and I've done like 4 pushes so far to my lab.
Good.
Okay. So on my 5th push, right, because I have finished one part of the thing and I wanted to push it, GitHub showed me an error, and I tried doing the push, and it gave me an error that failed to push some references to GitHub. So I was like really confused because I didn't have that issue before.
So what you're saying is when you push, it doesn't push?
Yes, it doesn't.
That's very interesting because unless you have any conflicts, which might be the case, then the push should work okay. So something you can do, given that this is a very specific question. In the meantime, what I would advise to do is look into what would be the message. If it says that you have some conflicts and this is the reason why you cannot push, you can try to do a git pull before you do a git push. Because on the announcement I made on Avenue, especially because I modified the make files, etc., on the GitHub repo, you might have some conflict. So I said one of the steps is that you can in fact do a pull and then do a push again. If you did a git pull and then a git push, but it didn't work out,
Okay.
please come to office hours and then we can share screen together and see what's going on.
All right,
Sorry,
I'll do that. Thank you.
okay, good. Yeah, thanks.
Yeah, thanks so much.
I had a quick question.
I mentioned, I guess on Wednesday on lectures, is currently Git auto grading because we reached the limit of the running thing. It will not give you correct results. It will say that auto grading failed, but this is not because of your mistake. This is because of the environment itself. So nothing changes from your side at all. Don't worry. You can still do exactly the lab that you do. In fact, push as much as you wish as well. That's not the problem. The only thing is now don't look into autograder or this X-rayed sign that you have there. But what if you want to check your code, whether it's correct or not? What can you do? You do exactly what you did before in Lab 0, which is running your code on Eclipse locally. You will run all the test cases, including the ones we give you and the ones you add, and this will tell you which ones are passing and which are not. So you can still check your code locally. In fact, the autograder GitHub visualization is just an additive feature, and it's more useful for us as graders than to you. So don't worry about it for now, because I received multiple emails about this, and I'm aware of the problem, but nothing we can do, in fact, in the meantime. Ian Rand, Lab1 tells us to brain thing, but I thought we weren't supposed to use braintf. Yes, if you look into my announcement, Ian, I said, and in fact, I sent an email to everyone as well, do not use any braintf statements, even if you are asked in the lab document to do so. I wrote them out, but as a comment, so they aren't one. I see. Yeah. So, Karina, yeah, you can do this. In fact, you can even run them locally to check your code if you want to look into your results. I usually, and personally, I do braintfs a lot to see myself how my code is going on. But once you submit, please comment these out such that they don't run into the GitHub repo and they don't run to us when we try to grade. Thanks.
I have a quick question.
Go ahead, Arjun. Yeah.
I was just wondering, so if we're working on our lab and say we get partway through a solution and then we realize that, there's a better way of doing this or a way that we could optimize it, and we go with a different route to solve the problem, do you want us to just delete our old code, or for continuity's sake, should we keep it but just comment it out?
Good. Okay, you can do both. One thing again that is good about Git for you and for us as well is if you have, assume for example, for a question you came up with a solution, it works, it passes the test cases, you push it, great. And then afterwards you think more about this, or you say maybe I should try another way. It's a good exercise that you are highly encouraged to do so. Then with even if you deleted your original code and then you submitted the new one, the old one would remain in the Git history, right? So you can even still
Right.
see it in your commit history, right? And this is something again that is good about Git, that you can still see your old versions of code even if you overwrote it. So you don't need to comment it out. Git, one of the things that it addresses is different because it's called version control, right? So as if you have different
Right.
versions of your code. Then what I'm saying is that maybe the modular solution is just remove the old code, update your code, push it. Don't be afraid that you are losing the old one because it's still there in the history, right?
Okay.
Good, thanks. But yeah,
Thanks.
as I said, you are highly encouraged to think of different solutions, right?
Okay. And then how do we view the version history?
If you go to your GitHub, maybe okay, let me put this in the list. It's good for everyone. I guess I have done this in the previous tutorial, but I can do it now as well. It's something that is very good to discuss through tutorial times because it's a very good feature in GitHub. So I will do this maybe once we start in 2 minutes or so. I can open the Git and show this to everyone. Okay, let me see the other questions here. Do we have to use curly brackets in if statements and for loops? Some of the test cases are missing curls. Okay, Michael, that's a good thing. So if it's a single statement, you don't have to, because the only purpose of these curly brackets is to include uh, in one block of code all the statements. Tell the compiler what is the start of the if body and the end, or the else, or the for loop, or whatever the block it is, right? But if it's a single statement, then it's the single statement by default, right? This is why maybe some of the test cases don't have these, because we were just, for example, doing a for loop that is having a single statement of comparison of the actual versus the expected, right? But as I said in previous lectures, you are highly encouraged, and it's a good programming practice to always have these curly brackets, even if you have a single statement, because if you develop your code afterwards, maybe coming week, and then you add a debugging statement or you add an extra statement, most likely you might forget to add these curly brackets. So from the beginning, once you do an if, open curly brackets, it's a safe side. It will always work, whether it's a single statement or not. So a good programming skill is to always to add it, right? But it's not wrong if you didn't add it for a single statement body if or for or while. And this is what I guess what you are referring to in the test cases. Elizabeth, how detailed should we make our comments for the lab? That's a personal judgment. Currently in lab 1, you are not penalized for not very detailed comments or clear ones. I'm just trying to educate you and train you to add some comments for code, because this is how a professional code should look like. But there are no specific instructions for lab 1. More details will come later, but for now, like, have your own personal judgment, right? It doesn't have to be very detailed. It's not a report. And if you add a lot of comments, or you add many lines of comments, this will hinder readability, right? So you also want to trade that off. So it should just be very few, maybe a single line, 2 lines that is explaining your algorithm, for example, right? Moaz, are these slides posted on Avenue? Not yet. And as you will see, these are not really slides. They are just examples that we're going to look into together, but maybe I can post them anyway. Nicole, do we need to replace the make, run, and make files? Because I don't see how to do this. Yes, Nicole, like as I said in the announcement, it's very easy to replace. What you can do simply is just copy these files that I sent on an announcement or an email as well, and paste them in the folder where you have your Git repo. It will ask you to replace because you already have these files from before. Then say yes, replace them, and this is simply it, right? In Eclipse, maybe you do a refresh to make sure you reflect the new files, right? Abigail, can we not use the power function at all? Yes, you are really encouraged not to use it. Power function has some, okay, that's a very important point to make. I know that the tutorial time started, but maybe part of the tutorial time is in fact to address your questions, guys, especially if they are related to the lab, right? So what I'm saying is in lab 1 or even in further labs, if you can do your lab without using the power function, please do so. I will give you one example for lab 1 that has a problem with the power function. And this is a reason why it might work for some of you and some will not work for. Power usually, the way it's implemented in the C standard library, it takes inputs as double and it returns double, right? But in our question that most of you are using the power for, I guess this is the Pythagorean triangles. Those are integers. And when a function takes input parameters as double, but we pass ints from previous lecture, you will know that this is called casting, right? The int will be transformed into double. But because of this transformation, different tool chains would have different approximations. And not most of the time, I would say not all of the time it works correctly. So please don't use the power function if you feel you can do the code without them, right? How do I append an array? Ayman here. If you mean by appending increasing its size, C has fixed size arrays. You don't append them. You don't increase their size. You define their size from the beginning. Later in the course, we will deal with dynamic memory management, where you can increase your array sizes because you dynamically define them. But if your question means how you can assign a value to an array, for example, you already defined a static size array, but you won't say, for example, array 1 equals something, then it's just a direct assignment. This is not appending. So please, if I didn't address your question, let me know because you might mean two different things. Karina, how come when we look at our submitted code on GitHub, the spacing is all messed up, like the tabs aren't equivalent to the code we actually wrote? Is that an issue? Karina, this is most likely because in Eclipse, you might be using a combination of tabs and spaces. Because as far as I know, GitHub keeps your formatting intact because it doesn't touch the files at all, right? And when I submit a code myself, like even the starter code, it doesn't mess it up, right? So what I'm saying is maybe you are using a mix of spaces and tabs. And because tabs in different machines can have different number of spaces, for example, it might be 8, like tab will be translated into 8 spaces in your machine, but it's 2 in my machine, 4 in someone else's machine, then this is maybe a reason why things get messed up. But if you are using all tabs or all spaces, this will not happen, right? Let me make sure I mute everyone because some of you are playing music in the background. Okay, John, can we use other compilers to use print and test the code and then implement it into Eclipse? John, yes, you can. It's nothing is preventing you from doing this, but why? I mean, Eclipse is already providing you with the toolchain, and you can even use printf if you want, right? And then comment it out after you test it. So the main purpose of the Eclipse is to have a unified programming environment. I'm not sure what other compilers will add to you. Eclipse already has its own C compiler. You can do whatever you'd like to do locally, test your code, and then before you submit, you can, for example, comment out your printfs, right? So it's not encouraged, it's not recommended that you use different tool chains, different compilers. You'll get confused and you will waste your time anyway. So just stick to a single environment and save your time for development, right? VibeHab, do you post these tutorial slides anywhere? The videos are posted, and previously we didn't have slides. This time we have some examples, but might be I'll post them if you would like, guys. Man, just an update. I did this git pull and git push again, and it works. Perfect. Thanks. If we're expecting positive integer input, should we check that in our function? If the input is negative, should we accommodate for that? This would be a good exercise. If you are accommodating for misbehaved user input, you can do this, and this is a good thing to add. If you are not asked to, that means you are not obligated, but you can add it anyway. Ishmam, when I try to run my code, I get launching file name has encouraged a problem. Okay, so in this case, like it seems to be a very specific lab question. It might be addressed during office hours. We can share a screen and discuss. Katie, for question 4, do we need to implement a line of code that makes sure that the integer is positive? I guess I already addressed this, Katie. You can, and you are encouraged to do this kind of guarding against inputted user format, or in this case, it will be coming to a function for you. But if you didn't do, and it's not stated in the question you have to, then don't do that. But I mean, you don't have to, but you are encouraged to do so. Rafi, for question 2, since there are negative test cases, can I use the apps function or no, since the top of the lab doc says only printf? Don't use the apps. Okay, something also about the power function. In fact, I added this line out about only printf and scanf because to guard you against any of the math library functions, including the power, because I knew it might cause some issue, right? And the apps will also apply to it. The apps will not cause issues, but don't use the apps. Do your own check. Okay. Okay, good. So yeah, so I will stop taking questions now, start on the tutorial, and then maybe after some time I can take like every 10 or 15 minutes I can look into the chat. Good. One thing maybe from Arjun question that I can show you is how to check your history in GitHub to see different commits and look into your code at different versions, right? So, okay. So I will share a screen in my desktop. Let me see. Okay, good. So I hope you all see, this is your lab, Arjun, and I will use it as an example, given that you are the one who asked the question. So what I have done is this is your repo for the lab, which you have access to. Here, you see the number of commits you have done. If you just click this link, it gives you all the history of the commits. The first 3 ones are our own starter code, auto-grading, setting up the environment. Once you accepted your lab, it seems that here you see that we are the creators. And afterwards, you have done 3 commits. If you click any of them, for example, here you updated the README file. Something that is very interesting, it shows you your changes, the ones you added and the ones you removed, right? So it's a visual way of tracking your changes, right? And here it tells you there is one file change. If we go back, you check another history. It also gives you the files. Here you change the single file, what you added and what you changed. So this is how you can check your history in GitHub. And it's a very useful tool for everyone. In fact, GitHub also has a desktop program that you can download in your machine and use to also visually look into these things locally. You don't need to go to the browser, but it doesn't really matter. I don't want to confuse you with that. But using the browser is more than enough if you want to look into your history, what you have done, what are the changes you have made in each commit. Good? Okay, so let me here, given that I'm doing this, online GDB, okay. And here I should select C. Good. So let's see what we want to do. I will go back to my desktop here. Sorry, my laptop, and then open the tutorial thing. So what I wanted this tutorial to be, given that this is the second tutorial of Lab 1, and we have already addressed Lab 1 questions in previous lectures, is to walk you through some of the examples and also address your questions. Good. So we will go through some of the sample examples together. I know that in the past 3-4 lectures, we didn't have a chance to program together or have hands-on examples because I wanted to touch more on the theory of the stuff, which is usually boring to me and to you as well. So let's leverage this tutorial time to look into how to think about algorithms together and how to program them, right? So I have kind of some examples here. Maybe we don't have the time to go through all of them, but I want you to see with me how to think about problems. Some of them are very similar to the lab, some of them are different, but the purpose is the same, is to get you some practice into the concepts we learn in the lecture. So in the first example, what we want to do is we want to write a program that computes the sum of all the perfect squares in the range from something to something and prints the values on the screen, okay? So just to be able to write this algorithm, you need first to understand what is a perfect square. A perfect square is a number that its square root is in fact another integer. For example, 9 is a perfect square because its square root is 3, which is an int. But 8, its square root is not an integer, it's not a perfect square, right? What we are asked to do is from 20 to 3, are you seeing the writing? Okay, yeah. To 3000, we want to identify the squares, the perfect squares, and Cameron, yes, the examples, I will post the slides, don't worry, and the recording will be there as well, right? So, so we want to identify the perfect squares in this range and get their sum. Let's first try to see how to identify them. Can someone imagine that? How can we get, first of all, how can we determine if a number is a perfect square or not in an easy way? Any ideas? And you guys can unmute if you want to comment. That's okay for now. Just a square a number. Okay, but Daniel, if you square the number, it will give you the result. What we're looking after is, okay, so this is one thing. Yes, you can square the numbers starting from 1, but you have a specific range from 20 to 3000, right? Multiply by itself. Yeah, so guys, we are not looking into, that's just, let's focus, right? We are not looking into, so what we want to identify is the perfect squares in this range. Yes, I can take numbers one by one, square them, and then see if the result is within this range, which means the result itself would be a perfect square. That's a way, that's correct. But what is an easy way? It's a trick that we can utilize from previous 2 lectures. Does T have a square root function? Yes, C has a square root function, the math.h, and we can use it in this example. So Rafi, what will you do if you are allowed to use a square root function? What do you think? Any idea? So, okay, let me see the chat. If a square root of a number is an int, great. So how to check that? You guys are moving in the right direction. So using square root and then check if this square root is an int. How can I know whether this square root is an int or not? And check that the reminder is 0. Oh, but there is no reminder of square root. Reminder is just for okay, Daniel, int square, double square. Yes, that's casting, Moaz, that's correct. So you guys went into the right direction. So the thing is square root function. So if I'm taking every number here, so I'm writing my algorithm. So I'd say for every number here, call it I. The idea is if the square root of I is int, then that's a perfect number. How to determine this? You guys said it correctly, using the casting and checking whether it's int or not, because square root returns generally a double, because not every number has a square root that is int. So what I can do is say, okay, I will do the square root of I. This is returning double. Then I will cast this into int. One last step that you didn't say is if you cast this into int, but it was something that is not int, for example, 3.5, right? If you cast this into int, x will be, what will be the value of x? Can someone say? It will be 3, correct. Then that means it's not equal to this. What is the condition that this I would be a perfect square? Is that its square root result, which is double, is equal to the casting of the int, correct? I will come into your comment now, Desmond, but let's focus on this there. It wouldn't in fact be more effective, but let's see, right? So given that we have this algorithm now, let's see how we can try to write this into online GDB, right? And I will encourage you to kind of also not just look into me but writing it, but try to write it yourself as well. The main purpose of this example is to show you how we can have a useful use or an effective use of casting to do something meaningful, okay? So first of all, I want to use the square root, so I have to include the math.h, right? And then maybe if I do this as white, let me see. Just move this here. Is that better? I guess this might be better for visibility. Okay, let me know if you think the other one was better. Let me know. And then now I'm defining. First of all, I would define my call this input, for example, and then I define my input. I would say input square root, something like this. This is integer square root, and then I define the usual double square root. And then I have my range, which is for, okay, here I would have iteration. But okay, I'm using this as the input anyway. So I'm saying for input equal, what is the number we said we are going to use? Is it 300? Let me see. It's 20 to 3000, okay. So input 20, input less than 3000, input plus plus. What I want to do, I want to get the square root of the input. So I would say, and this is a normal one. So I would say this is I will use the double, and square root is, if I remember correctly, it should be that. And then I'll do the square root of my input. And then I will cast, so I will use the integer variable. Here comes the trick. You just simply do this, right? And now you check, you say if I square root equal d square root, then maybe I just print for now. Let's forget about the sum. And to print what I want to say, my input. So in this case, it should be d, because I know it's an int, is a perfect square. And then I will just put my input here. Good. Let's see if this works. Does this make sense to you? I hope it works.
Didn't you just assign I square root to d square root, and then you're checking the equality right after? So wouldn't it always be true?
That's the trick, Arjun. Okay, that's you asked a question that is vital here. So let me comment on that. So Arjun is saying the following: I assign this variable to this variable. That means if I check equality, they will be the same, right? But no, because this is casting, and this is what I want you to understand. If you cast double to int, then the result will be the truncation, right? Let's take an example. Assume that d square was 3.5. When you cast it to the integer value, it will be 3. So if you check equality, they will not be equal, right? They will only be equal if the value of the double variable, so let's say this is the double one, it will result in an int like that. When they will be equal only if the original double value was really an int, correct? And doing that, this will only happen if the original input was a perfect square. Is that correct? Maybe one thing I'm missing here based on the compiler is maybe I need to cast this into double to the equality for the equality to work. But let's check if it works, right? Let me pick questions. Again, I see many things on the chat. You guys, are you commenting here, or you're just, please, if you have questions, just add this into brackets as we said before, such that I don't have to read all these 53 messages if they are not questions, right? Let me see. There is the include on the top of the main. Yes. Okay. I have done the include already, if this was a question. Good. Okay, so let's try to run and see, check our luck here. Okay, 25. Oh, I forgot something. Maybe formatted new line, right? Okay, so it tells you 25 is a perfect square, 36 because 6, fine, 5, 6, 7, 8, 9, 10, etc., etc., etc. It works, right? So this is the trick. Let me go back to Daniel's question, which is, would it be more better, or maybe at least, and it's another way of doing things, if you take the if you do squaring every number of int, for example, starting from 1, and then see if it's between 25 and 30, right? So it's a different way of writing the code. Yes, this in fact will work, because you know, if you take the square of an int, it will be an int, and if it's within your range, that means perfect square, right? So you can do this as well. But I have done this way because now, first of all, previously you needed a for loop that is starting from 1. Here you are just starting within the range, so it's better readable. The second thing, I wanted to show you how to better use the casting, because this is what we covered in lectures, in last 2 lectures. And now it might be clear to you why it might be useful to leverage the casting as a trick, right? In order for they are equal, both values will be casted to double, right? So that's a good question. This is what I said. If it doesn't work, maybe I need to cast this to double. But yes, generally you are correct. Remember what we said previously in the Wednesday lecture, is that if you have an expression that have different types, we will cast everything to the wider type. Here we are comparing int and double. So what will happen by the compiler is that everything will be casted to double to check the equality. That's correct. Good. So now, after we have done this, let's see if I want to do the sum, because the question was mainly about the sum, right? So now, after printing this, maybe I need another variable here that I call sum. And then I would say sum plus equal input in this case. Is that correct? Am I missing anything? What do you think? A question to you guys. Am I missing anything?
You just messed up the printf when you hit enter.
Oh, that's bad. But that was unintentional. This wasn't my question, but thanks. Okay, so is that code correct, or there is something that is missing? Initializing the sum amount. That's correct. Sarah as well. So because remember what we said before, I guess this was even the first lecture, is that variables in C are not initialized by default, right? So they take whatever value they have in the memory assigned to them, which might be garbage. So you need to initialize to 0 if you want your sum to work correctly, right? So here I want to make sum equal 0, right? Good. Okay, good. So by this, maybe at the end, I would just print the sum. I would say the sum of all perfect square in 23,000 range is sum. Another thing, here we are not including, so we are including the 20, but we're not including the 3,000, correct? So if we're talking about math, we are talking here about a range between 20, so 20 is included, but in fact, 3,000 is not, right? This is how we write it usually in math, right? But if we were to add the 3,000, I mean, we don't know whether yet 3,000 is a perfect square or not. It can be, right? So what I need to do is to do this, right? If I want, right? So by doing this, you are also including the 3,000. So, okay, that's the code. What if I want to write this as a function? Because we have covered functions and we said this is the right way of writing things. So what I want to return from this function, the sum, which is an int. So I define my return to be int. And then I may call it sum of, I don't know, perfect squares, right? And then let's say for now, I don't take any input because my range is fixed. Then I will do this code all there, right? And then maybe at the end, I would just return sum. And then here, to call this function, this is function body definition. To call this function, I would simply say maybe doing exactly the same thing, but here call my function instead. So it would be of perfect squares. So by doing this, you are calling the function, right? A simpler way of doing this is just you define an int sum here equal that, and then you just print the sum, right? Doing it in a two-step way. Good, because this is returning int. So whether you put it here or you define it in a variable and then put the variable here, it's the same thing. Good. So what we have done here is we define the function that is doing exactly what we want, and we call it here. This is the function calling. We said the function has three things, right? A prototype, a body or implementation, and caller, right? Here we called the function, here we implemented it, but we didn't have a prototype. What is the reason for this? Why we didn't need a prototype for the function? I want the tutorial to be more interactive. Just we'll make sure do need specifier in the printf. Ah, yeah, that's exactly correct. It should be D, thanks. So let me see the chat here. So what I was saying is why I didn't need a prototype, because it's all in one file. No Nicole, that's not the reason. Because it's before the main, Zauhan, that's correct. Because we added it before the main. What we said is you need the prototype because the compiler will start executing from line 31, the main, right? Move line by line. In the first line, I find that I'm calling this function. But if I have done this, you know what, maybe let's try this first. Okay, it works. Both at the main and at the function itself gives the same number. But now let me move it after the main and try to run. Oh, there is a problem, right? Here is just a warning, but in fact, some compilers will give you even like a syntax error. And the reason is it says implicit declaration of the function. Why it's implicit declaration? Because the compiler started from here, it found a call for the function, but it didn't find the implementation yet. To remove this warning or error, we need to add a prototype here that is exactly the same line as the function definition with a semicolon. If we do this, you will not get the warning or the error, right? And the reason is you already told, like you have already told the compiler that there is a function coming that is called that. So when you incur it in your main, don't worry about it. I'm implementing it later. This is called function prototype. This is the function implementation itself, or sometimes called definition. And this is the function calling, right? So these are the three functions, different aspects of dealing with functions in C. Let me see if there are questions before I move forward. Do you guys have questions? So is that what you would put in the .h file? Moaz, that's a good question. Because we are using the online compiler, it might be a little bit problematic to add multiple files, but you are correct. What I would put, okay, so what I would do is I would take this into the header file. Let me call this, I don't know, my perfect square, something like this, my perfect square.h. And then for the implementation, this would be your exactly same thing, but it's .c. And here you have to include, come on, you have to include this one. Okay. And then coming in the main here, you also have to include that, right? You would do that. Right? So if you are splitting things into files, right? This is the first file. This is the main file. Call it anything. This is the C file for function. implementation, and this is your H file for function implementation. Talking about the lab, right? So let's think of the lab, because this thing that you have seen yourself, right? Implement. So in the lab, we have questions.h, which includes all the header file, all the prototypes of the functions. We have questions.c, which is the one that you are implementing. And we have the main in the test cases.c. And in fact, not the test cases.c, if I remember correctly, it's in all tests, but basically it's one of the test files. And this file, if you look into it, it will include the questions.h, right? So it's exactly the same thing. You added different functions in C and header files, and then you included the header file in somewhere else where you have your main, such that you can call your functions from the test cases. I hope this kind of multiple file thing is clear now. Let me see if there are questions. Okay, good. So let me, so we can take this question further. I don't want to spend more time on this to look into the remaining question, but it's just a good exercise anyway. So something we can do is, instead of just having this as a fixed range, let me go back to all, okay, let's even keep this. Instead of having this as a fixed range, I can even take start, end, correct, as my range, and here deal with the start and the end, right? What I have done here is, instead of not taking any inputs, I'm making my function flexible to deal with any range, right? By taking 2 inputs. I have to update my prototype as well. Correct? And then here, I need to pass something. If I'm passing 20 to 3000, it should give me the same result. But now, in fact, I can do 1 to 10, right? And then if it's 1 to 10, what should I get as a square? 9, right? It's only on 4 as well, 4 and 9. So let me try to run this, and hopefully should be okay. Oh, because I added this include bad thing here. Okay, so you get 1 because 1 is the perfect square of itself. 4 and 9, right? But here we are still printing the same message. So if I want to update this printf as well, what I can do is, it would be d-d, and then here I would add start, end, and sum, right? So it's a good implementation to have multiple inputs and see how they are formatted, right? And I do the same thing here. But here I don't have a start and end. I would just give the number that I provided to the input. What I have done. This is a start and end, which is correct, but in the main, I don't have a start and end. This should be what number I give, 1 and 10. Right? And then if I run, the sum between these ranges, it's returning the sum. So 1 plus 4 plus 9 is 14, right? 14. Is that clear? Do you guys think that doing this kind of exercise like online together, and we try different alternatives and see how we can think about problems, is useful? Okay, good. Okay, so let me know, again, like to make it more useful, have it more interactive, like ask questions. Like if I ask a question, like try to think about it and address it, even if it's wrong, but it's good to address the way you think, because this is the most important thing in programming, is not being able to know the syntax. It's more about like the mindset, right? Okay, let me go back to the slides. And let's see the second example, right? Okay, so here we want to write a program which reads in a number n and then print the following shape on screen, where I believe this shape is, you start by n stars, right? Let me see how many stars are these. 3, 3, 6, and 3, 9. And then here we have 3 and 6 and 7. So you decrement by 2 each time, right? So this should be your n. This should be your n minus 2, n minus 4, etc., etc., until you reach 1, right? So let's think together how to do that. Like if I want to do, and here there are no spaces, but here we have 1 space, 2 spaces, etc. How to do that? How to start even approaching this problem, right? I'm getting n as an input, so I already have that. The first line is very clear. I'm just printing n stars, right? So having a for loop that prints n stars, right? So that's easy. Starting from the second one. So this is a special case of taking the input as well. But starting with the second one, I want to do 2 different things. The first one is decrement the number of stars by 2, but also have a starting space at the beginning, right? Because here there is 1 space, and here there are 2 spaces. Here there are, as you can imagine, 3 spaces, etc., etc., right? So you need to figure out 2 things, and this is how I would approach it. Figure out 2 things. What is the number of spaces each time you print, and what is the number of stars? With regard to the number of spaces, it starts by 0, and then 1, 2, 3, 4, etc., until you reach n, correct? With regarding to number of stars, you start by n minus 2, n minus 4, until you reach 1, right? So it's like you have 2 opposite direction 4s, right? One that is starting from 0, the other one is starting from the number you have. Am I correct? Right? And then to print the stars, you cannot do this using a single 4. In fact, you need another nested 4, because for each time you need to go through this to this, right? So let me kind of go into the code and see how we can think about that together. Okay, so now I don't need that. Just okay, let's simplify stuff. Simplify that. Then let's go here, right? First of all, I'm reading n from, now let's make it from the user, right? So I would say, okay, print f, please input an integer number. And then it's new line. And then now scanf, that's something that is pretty easy. Then doing this is an int. And then I want a variable to read this in. So I will call this, I don't know, num, right? Something like this. Or n, here is called n, so let's call it n. And then I'm assigning the number to n. So the first step is done. I have read the n from the user. Now I want to loop, because how many lines I have, if you go back to the original, to the slide, how we said we print n stars up to 1, right? Which means you have n lines, right? So the first one is you need, okay, we don't do this in previous anti-C, so I would say I'm defining here an I, not initializing it. So I equals 0, then I is less than n. So starting from 0 to n, do this n times, and you do I plus plus. So this for loop is just for the n lines, right? Great. And then now I'm inside the line itself. So I'm, for example, I equals 0, I'm in the first line, right? So what would I do? If I'm in the first line, I want 2 things. First of all, I want number of spaces equals 0, because I don't start with spaces in the first line, but I want to print n, I want to print n stars, right? So now I need another loop. So I'm defining j, and say for j equal 0 to j less than what? Now I need to think about the logic, right? So let's say I'm saying j is less than n for now. I'm just thinking with you. Then j plus plus. And then print f. First of all, there are no spaces, so that's good. And then I'm printing a star, so just a simple star, right? Good. And because I know that each time I exit a line, I'm going to print in a new line. So here I'm printing a new line, just simply new line. Good. if I do this, so let's see your suggestions here. Line 23 isn't commented properly. 23. Wait, I don't think an input n will result in n lines. Well, that's not commented. Okay. Why? So Yanha, like if you have an input of n, let's say for example I'm inputting for n as a 4. So you need to print 4 stars, 2 star. Oh, you are correct in fact, because you are decreasing by 2. That's an excellent idea. Good. So yeah, that's in fact perfect. So let's see now the general rule. In fact, I need to go back to the slides to show you the algorithm itself. Yes. Then here, where is that? Here. Okay. So if I have 4, what I would have 4 stars, 2 stars, and then 1 star, right? Perfect. So this gives you 3. How to determine the number of lines you have? Each time you are decrementing the number of lines by, each time you are decrementing the number of stars by 2, right? So here, if you start by 4, you have 4, 2, and then finally you would end up having 1. So let's deal, okay, that's a good point as well. Let's deal with odd numbers first because they are easier. Here. So I'm starting 5, 3, 1. Good. Which means each time I am decrementing by 2 until I reach 1. So a different way of doing this, but how many lines I would have? If you have 5, you would have 5, 3, 1. To get the number of lines, I would, okay. Keep hopping up, but let's see. Here, something I would say, let me start from n because I know this is my number. And then I would stop when I is less than or equal to 1. And then I would say I equal I minus 2, right? So if I have 5, I would have 5, 3, then 1, I'm done, right? So doing this, it will give you the number of lines and number of stars you need. Good? And then now if I do that here, in the first line, I'm going to print a number of stars equal to n itself. But in the second time, I'm going also to print number of stars equal to n. So I want, maybe I'll stop here and ask you, how can I modify that?
For that for loop that you just edited with the I equals n, shouldn't it be I bigger than or equal to 1?
Yeah, that's correct. Yeah, thank you. So let me ask, yeah, that's correct because we are decrementing. So for 25, if I keep doing this, each time I'm going to print n stars, but this is not what I want, right? So by this one here, we fixed, as Zanhao said, if I remember the name correctly, we fixed the number of lines, right? We fixed number of lines. So that's not n lines, in fact, right? It's n to 1 lines. But here, I want to fix the number of stars in the line. What should I do? N for header just j less than I. That's correct, because here, given that I know in the first line, I is n. In the second line, I is n minus 2. This is exactly what I want to print. If I go back to the slides, for the 5 example, I want to print 5 stars, which is my n, and then print 3 stars, right, which is minus 2. So what I would do is I, and then increment, right? Good. So is there anything else that I'm missing, right? There is still one thing I'm missing. So let's try to run this and see what we are missing. It's just 5. Great. We have 5, 3, 1. But there is still something wrong, right?
We're missing the spaces, no?
Spaces, exactly. How to do the spaces then, right? Because this would be interesting, right? Remember, we said we want a number of spaces at each line that starts from 0, 1, 2, 3, 4, etc., right? So if here I do print f. Okay, I will do the simple thing first, but then I will show you how to do a more sophisticated thing. So we want a number of spaces, so I would add another loop. Just the straightforward thinking, n, k, and then this is my loop for the spaces, k equals 0 because it starts from 0, and then k equal, okay, in the first line 0, the second line it's 1, 2, 3, 4, etc. So how would I know how many spaces I need each time? It should be less than or equal to j, right? And then k plus plus, because if you are in your second line, oh no, it would do something different. If I relate this to I would say it should be n minus I, and then k plus plus, because in the first line n minus I is 0. The second line n minus I would be yeah, it would be 2, but I don't want this to be 2. I want it only to be 1. So I can either do that or relate it to the J4. But let's first do that. Print f, then do a space. I tried to save as usual, but okay. So let me see your comments there, because you guys might get confused. Do you have okay? Yeah. Now this is what we want to achieve ultimately, but let's see. I mean, I'm simulating this spaces in numbers by the for loop, right? /g is a tab action, right? It's not a space, and we want spaces, right? How you're trying to come up with an equation, which is I guess exactly what I was trying to do here in the relationship between n and I, but we will see if this works. I'm just thinking with you, right? Sarah, would be 0 for even numbers though. I will come to the even numbers case now. Let's talk first about that. If even, I know time is over, but let's continue at least this example, right? So let's run and see. I'm inputting 5 here, and then I got, oh, I get one space, but I got also spaces. How did this happen? Because yeah, that's my mistake. Can someone say why things ended up like that? Lecture is done. Yeah, I would just finish this example and finish, but feel free to leave if you like, and recordings will be posted anyway. Because you did this in the for loop exactly, and how? Because I included this space for loop inside the original for loop, which means for each printed star, you would have the space, right? But I want this outside. I want only the spaces printed out at the beginning of each line, not for each star, right? So to do that, I'm just putting this out, which means here, if I'm commenting, start by printing spaces, and then now print the stars, right? Okay. Be 5, and we got exactly what we're looking for, right? So that means that ultimately the algorithm we're looking at is the following. First of all, determine the number of lines. So if I'm just organizing my mind, I would have come up with a solution in 1 minute at the beginning and just give you the solution, but I might need to do this in lectures, but not in tutorials. I want to walk you through thinking about an algorithm or a question in the exam. So organizing the steps for those who are confused. I want to first identify number of lines as a function of the input n. First step. Second step, start by printing spaces, which is also a function in which line you are in. Start by 0, then move to finally n minus I over 2 spaces. So come up with the equation. And then third step is print the stars, which has to be n minus 2, right? Each time n minus 2. So these are the 3 steps we would do. Now come into the even things. Okay, let me first check questions. I have a space before the first line. Is it? Because initially I is n, we shouldn't have any space. Oh, because it's true. Okay. Okay, that's an excellent point. So we shouldn't say equal, or maybe start from 1 if we, okay, let me see. I want first 0 and then, okay, I guess this would work. 5. Yeah, good. Question, how do you make sure that spaces are added on both sides of the stars? Ahmed, that's as they were answering you. I only need the spaces, given that I identify the correct number of stars and spaces. Once you fix the stars at the beginning and you do a new line at the end, that they said they will just be aligned as you wish, right? You don't need them. Okay, good. So if there are no questions, one final thing to conclude with, which is what I would do for the even numbers. Now, and this is also another skill that I wanted you to do. If you come up with such a question in an interview or an exam, if you started by the complex special case, like the even numbers, for example, you are kind of loading your mind about thinking in an additional problem. Try to do this divide and conquer principle in your thinking, right? Take the easy one first and then build on top of that, right? So now, given that we have a solution, how to generalize this? This only works for the odd numbers. But if I run the even ones, like for example, I would have 4. You get something like this, and it doesn't print you the 1. The question is, do you really want or not? Like, do you want to print a 1 at the end? Or you would say, I'm just stopping at 2 for the even numbers, right? This is a requirement that will depend on the question. So you either stop at 2, like what we have right now by default, because you will never reach the 1, or you would say, you know what, maybe at the end, if it's an even number, I would print a 1 star at the end, even if it doesn't align. What I mean by this is, I can come here and say, if n2 equal 0, so it's even, I know that 1 is not printed, so I want to print a star at the end, right? If you want. And this star, you want it to be printed with a specific number of spaces, such that it aligns, in fact, it will not align between the 2 stars at the end, but for example, you might end up using the same number of spaces you have done at the end, right? So here, you know that I would stop at 2, which means now you would say, I want to print number of spaces equal to that. And then afterwards, I would just print a single star, which is this thing. So let's see how this would look like. Again, the definition of K, but that's okay. So here is one. Okay, that's a good point. Here we define K, but why K is not defined here? It's in fact, we are still inside the main, right? What do you think? Why it's giving me that K is not declared? Local variable. Yes, it's a local variable, but what is the scope exactly? But what is the scope? We said previously that even if everything inside the main is still a local variable, but you have a specific scope. The scope of a local variable is the block that you define this variable in. Here, we are defining or declaring k inside the for loop, which means once you exit the for loop at line 38, k will be no longer available in the memory, right? It's not defined. But if you define k here, for example, here n is visible, although n is still a local variable, but n is defined within the block of the main. So anything within the main will see n. But k, another local variable that has a narrower scope because it's defined inside a for loop. Good. So here we are defining k again, and this is a different k than this one, right? Just to know. Let's try. The first thing is we want to make sure that for our odd numbers, nothing changes, right? Let's double check. And then for the even numbers, we got something like this, right? You can do this as you can shift it by 1 or remove it at all based on the specs. It's up to you, right? So this one is optional, dealing with even based on requirements, right? Okay, so by this, I will just stop because time is already over by 10 minutes, and I'll see you all in lecture. Everything will be posted, as I said, and I will post also the remaining 2 questions for you to think about. And if you have questions about them, we can discuss in office hours. Sarah, could you take a screenshot of the code and add to the solution to the slides? Yes, you have the recording anyway, Sarah, but I can try to post the solution as well. But something I would prefer to do instead is I would leave you to think about it. I mean, how I would study this tutorial if I'm a student. I would just look into the questions, try to solve them based on my understanding of this tutorial, and then look into the video to see if my solution or if I have question or nothing worked, why it didn't work, etc. So don't look into the solution directly. Good. Thanks everyone, and see you in 1 hour in the lecture. Bye-bye.